Welcome dear student to our YouTube channel. Today we will learn about the next portion of the electronic configuration. In the last class we have learned about the proper sequence of the subcells or orbitals according to Abba's principle. Okay. Today we will use that order to learn the electronic configuration in case of atoms. So let's start. So the orders are 1s, 2s, 2p, 3s, 3p, 4s, 3d. I have told you how to evaluate the orders from the orbital chart by using the energy sequence. So let's take some examples to understand the electronic configuration. So if I am taking the first element of periodic table, that means hydrogen, which has the atomic number 1. So anyone who don't know, that means X if is a atom of an element and Z is the atomic number and A is the atomic mass. I am writing here the expression of or representation of expression or representation expression or representation of an atom of any element. So if X is the atom, if X is the atom of an element, Z is the atomic number, Z is the atomic number, atomic number, A is the atomic mass, So always remember the Z, that is the atomic number, always express the total number of electron and proton in the neutral state of an atom. So Z is equal to total number of electron, that means I am writing here E for total number of electron, and which is equal to the P, that means total number of proton in the neutral state. Similarly, for I have show you the total how to calculate the electron number and proton number. So the next part is neutron number. So neutron is calculated by subtracting the atomic mass from the atomic number. Atomic mass is subtracted by atomic number, which will give the total number of neutrons available in an atom. So from this representation we can find out the idea about the three subatomic particles, that means electron, proton and neutron. So I am doing here electronic configuration, that means so in hydrogen atom I have written 1, means that is the atomic number, 1 also can be written here atomic mass, but there is no use of atomic mass because I am not doing any work related to neutron, so I am doing here electronic configuration, so I am using the electron number only. So here 1 electron is present as hydrogen is in neutral state, so the electrons will come first to the first subcell, that means the orbital, that is the 1s orbital, and here 1 electron is present, but S orbital has the tendency to occupy 2 electron maximum. So if we have 1 electron, so we are placing here, that means 1 is 1. Moving forward, for helium atom, the atomic number is 2, which represent helium atom contains 2 electrons, that means the first subcell or orbital is 1s, and here 2 electrons are present, which is the maximum tendency of 1s orbital, that means 1s will carry 2 electron. Okay, if we will draw box diagram which represent the suborbitals, that means I have told each orbital has their specific numbers of suborbital. That means s orbital has one suborbital. So here if you will draw the suborbital and place the electron here, so here is one electron. I have told in spin quantum number in the last class, that means in the suborbital atom contains electron, one in clockwise manner and another is anti-clockwise manner. That means the clockwise electron and anti-clockwise electron are present if the maximum or fulfilled number of electrons are present in the suborbital. Each suborbital, I have told, contains maximum of two. Each suborbital contains maximum of two electrons, one in clockwise manner and another is anti-clockwise manner. So here hydrogen contains one electron, so we can place it here either in clockwise manner or anti-clockwise manner. Similarly, helium contains two electrons in s orbital and it's also in suborbital, then two electrons present, so one will be present in the clockwise manner and another electron will be present in anti-clockwise manner. So moving forward, for lithium we are writing the atomic number is 3, that means the 3 number of electrons are present in lithium, that means the first subshell or orbital is 1s, that means 1s will carry maximum of 2 electron, that means 2 electron will go to the 1s orbital and then after fulfilling the 1s orbital we will move forward the next orbital, that means 2s orbital. We have 3 electrons but we have placed 2 electrons here, so the rest 1 electron will go to 2s orbital, that means 2s will possess 1 electron. So we are doing the suborbital representation for that orbital which has maximum n value. That means maximum n value shows the outermost orbital and the orbitals, we can say the orbitals which contribute the valency are represented by the suborbital, or that means the box diagram. So here the maximum n value is possessed by 2s orbital and the 2s will possess 1 electron and it will be represented by hydrogen manner, that means it may be a clockwise electron or it may be a anti-clockwise electron. So the total number of unpaired electron can represent the valency or the covalency of any atom. So we will discuss about the valency in the coming classes. So lithium, similarly you can do the electronic configuration of any element by choosing this sequence of the orbitals, or if you will need more suborbitals order, you can draw or you can bring it from the orbital chart which I have told in the previous class. So for electronic configuration there is another concept called as stable electronic configuration. So what is stable electronic configuration? So an electronic configuration is said to be stable when the electrons are present in the suborbital of orbital either in half filled manner or in full filled manner. So what is half filled, what is full filled? If p orbital has maximum of 6 electron, then p orbital will be stable when p contains 6 electron or 3 electron, which represents its symmetry or symmetrical arrangement of electron in the suborbitals of orbital. So if there will be symmetry in the arrangement of electron, the atoms get stable as the electrons are in stable arrangement in the suborbitals of orbital. So let's understand it with example. So moving for chromium, which is the atomic number 24, if first we need to draw the electronic configuration, that means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and final one is the 3d4. So here there is 10 electron, S12, it is 18 and it is 20 and the total electron is 24. So the electrons, here the electrons are present, which are present in the 3D orbital is nearly half filled. That means d orbital has the tendency to possess maximum of 10 electron according to 4l plus 2 rule, which I have told. The 3D orbital possesses 10 electron or 5 electron to become stable. If 3D orbital is stable, then 3D orbital containing atom becomes stable. That means we need to we have filled the 3D orbital to make the chromium atom stable. So 3D is 4, we need to make it 5, 3D 5. So here we excited the electrons present in the lower energy orbital. That means chromium atom which is present in the ground state. That means the electrons of the chromium atom is present in ground state are excited by giving certain energy, so that the electrons, I am not repeating these things, that means these things is constant in this here, so I am marking it with continuous mark, and the two orbitals, that last two orbitals, that is means 4s orbital and 3d orbital contribute for the stability of chromium atom. That means here the chromium atom that contains 4s2 electron will move its one electron to 3d orbital to make the 3d orbital stable. That means 3d orbital becomes half filled. So the 4s orbital, s orbital becomes stable, either it contains one electron or two electron. So s orbital is stable here, and all the rest previous orbitals are stable as they are fulfilled, and the 3d orbital becomes stable by receiving the excited electron jump from 4s orbital to 3d orbital. Why the electrons jump from 4s orbital to 3d orbital? Because they have nearly equal energies. So what is the energy of 4s orbital? So energy of 4s orbital, I have told the rules. That means the given n value in the LHS side and the L value of the fixed L value of the orbitals, that means the L value of s orbital is 0, that means the electron will be 4. The total energy of the so the chromium atom has the energy of 4. In chromium atom, the 4s orbital has the energy of 4. In case of 3d, the n value of 3d is 3 and the L value of d orbital is 2. So the energy of 3d is 5. So due to similar or nearly equal energy of 4s and 3d orbital, the electrons when achieve the energy of 3d orbital through excitation reaches the 3d orbital by moving to the outermost or to the outermost. We cannot tell it is the outermost, it is the penultimate orbital, because the outermost orbital is that orbital which has the maximum n value, and it is the penultimate orbital. So which orbital is called as penultimate orbital? The orbital present just below the outermost orbital is called as penultimate orbital. It's called as penultimate orbital. So here the chromium atom which previously or which in ground state contain 3d orbital shows unstable electronic configuration. So it is in this state, but in excited state, that means in the excited state chromium contains total half filled number of electron, which expresses its stable electronic configuration. That means chromium atom becomes stable when it is present in the excited state, not in ground state. Similarly, in case of copper, same thing occur. That means in case of copper, if we will take, the copper has the atomic number, that means 29, in which the 3d orbital contains 9 electrons, and the electrons present in the 3d orbital is nearly fulfilled. So the 3d orbital receives electron from 4s orbital. That means the electron gets excited from 4s orbital to 3d orbital. That means chromium, in case of chromium, the complete half filled orbitals are present, but in case of copper, 3d orbital becomes completely filled, which shows also the stability of copper atom in excited state, and 4s is half filled, which also shows the stable electronic configuration. So some atoms excites their but transfers their electron from lower energy orbital to higher energy orbital to become stable or to show the stable electronic configuration. It was all about the stable electronic configuration. So in the coming class, we will learn about the valency and how the ions are produced by using this concept or electronic configuration concept. So thank you. If you any have doubt, comment on the comment section and I will answer you in short videos. Thank you.